Okay, sounds good. Just like to welcome you guys all out. We're happy you could join us this morning. Um, I'm just going to give a quick intro about Eric, and then we'll go into the presentation, and then at the end we'll have some additional time for questions. And just during the presentation, if you ever have any additional questions, feel free to put them in the chat at any time. So a little bit about Eric. He started his career with the Advanced Engineering Group in Saginaw Steering Gear, a division of General Motors. He spent time working in the computer-aided design and engineering department before managing several lines in a production facility and managing a design department for American Axle Manufacturing. He has spent the last 20 years in the software industry, with the last 10 years specifically in autonomous systems and proving grounds worldwide. He has an understanding of the needs and challenges faced at proving grounds and how robots can help solve those problems. So yeah, we'll go ahead and turn it over to him.
Thank you, Brooke. Welcome. We appreciate you taking some time out of your day. We know everyone is super busy. When we talk about the world of durability, misuse, impact testing, the mechanisms that have been put in place to do a lot of that testing were put in place a number of years ago. For example, a rollover test. Oftentimes a one-sided ramp is used, and either another vehicle or a cable pulls the test vehicle up onto that ramp, and when it reaches a certain point, it rolls onto its side. Or it might be pulled down a rail, smashed into a pillar or a wall. In durability world, you have your human test drivers that drive the vehicle over those very, very rough roads for long periods of time. And when these tests were designed, that was the best that was available, especially in the misuse and the impact area. Unfortunately, they don't really give us an accurate real-world scenario. Putting a vehicle on a sled sideways on the end of the sled, pulling the sled at high speed, and then having the sled stop and letting the vehicle roll off of it doesn't really give us a real-world scenario. And the results of that is that the data can be either lacking, incorrect, misleading, or kind of some of all of those. And product developers, the engineers working and looking for those test results are then making decisions based off of that data that's not entirely accurate. The challenge with using human drivers is these scenarios can often be very dangerous to perform. We do have one customer that has a single person in their company that is qualified to do this jump. The picture that you're seeing is a vehicle jumping off of about a meter high angled drop-off in order to test the airbags and make sure that they don't go off when they shouldn't go off. This company has one individual that is certified and qualified to run that test, and so they fly this individual to Europe to run the test. They fly him to Arizona, to Australia, to all these different locations, wherever they're going to be running the test. And they have to install a roll cage, a special seat with a 5-point harness, a helmet, a chest plate, various other pieces of protective equipment. And even with all these precautions, there is still a fairly high risk of injury if something goes wrong during the test. I'm going to play a short video here. Hopefully you can see it, and it'll give a little bit of an idea on what we're doing with robot drivers in the testing world.
I feel like that was a recruiting video for Jason Ritter's team.
Could be. Could be. Quick question for you folks. Have you ever used robot drivers for durability, impact, or misuse testing? And you should get a little pop-up window that Brooke will put up on your screen. Just a thumbs up for yes or a thumbs down for no, if you would.
So far, we have 40% say yes and 30% say no.
Okay, great. So some of you have experience with using robots and some not. So let's talk a little bit about the purpose behind and the purpose how using robots. Excuse me, frog in my throat. The thing with this type of testing is it has to be run, right? OEMs have to get the information from the vehicles, and so they need to know that the product's going to last. They need to determine if safety systems are going to deploy correctly. They got to determine if the structural integrity is maintained on the vehicle. They've got to confirm that all those parts they're buying from vendors and putting onto their cars and kind of selling under their label are going to last. They need to set reasonable expectations for warranty projections. I'm fairly convinced from my time and working with various companies that there's probably nothing that OEMs dislike more than having to do a major recall or having a really high warranty repair bill because a part wasn't tested properly that they put into their vehicle, whether they bought it from a vendor or manufactured it themselves. Those types of things are really important to them for their bottom line. So the testing is critical. One of the challenges is that we as human beings are all driven by self-preservation, right? It's one of the really basic core things that drive us. And I know that at your facilities, this probably has never happened, but I have been on facilities where they talk about the fact that on occasion, human drivers may alter the parameters slightly or not quite drive it to the instructions in order to reduce their own discomfort and risk of personal injury. One of the challenges with these tests is repetitive stress injuries, and these are caused by prolonged exposure to abusive and bumpy roads that can cause back, arm, shoulder, hip, neck, that type of thing. There are a couple of examples, and you guys may be able to share better examples with me than I have, but we have one customer where they have a track that is severe enough that health and safety limits a driver to 30 minutes maximum in the vehicle out of a 2-hour time period. So they have to have 4 drivers on staff to test that vehicle. This facility runs 24/7. So they use 12 drivers over a 24-hour period to have one vehicle on the track. These folks owned 4 of our robots and were doing a fair amount of testing and wanted to expand. And senior management were not convinced that the robots were a good thing. They didn't know that they were getting the value out of them. And so they decided to run a blind test, and they didn't tell anyone till after the test had been run. But they went to their drivers, the human drivers, and gave them a profile and told them they needed this test profile to be run as quickly as possible. They needed the results. As I mentioned, they were running 24/7, and it took them 12 days, a little over 12 days to complete the test profile. They then gave that exact same profile to the robot group and said, run this, let us know how long it takes, and get us the results as quick as you can. And it took 7 days to run that exact same profile. So they got the results much, much faster. And not only did they get the results faster, but when they saw the overall results and how accurate they were, they ended up moving from 4 robots to 15 robots and are in the process of adding several additional robots this year as they continue to expand the robot drivers at their facility. Another example that we had took place on another continent. There was an American company that designs a add-on roll bar for pickup trucks. It's somewhat unique in that it splits in the middle, and you can move the back half of the roll bar to the back of the pickup bed, and now you have a rack that you can load things on, and it becomes a rack. They wanted to have some fairly extensive testing done on it, and the track and the location they choose to run those tests were on another continent, where they only run they have a single 8-hour shift a day that they run on that track. For safety reasons, they don't run at night or in the dark. So they quoted this company 6 to 8 weeks to complete the test. The driver was very limited on how much time he could spend in an 8-hour shift on that track in the vehicle that they had supplied. So based on all of those pieces of information, it was going to take them, they felt, between 6 and 8 weeks to run the test with the human driver. In the interim, they bought their first robot. And when this group from the US arrived, they said to them, how about we put a robot driver in? Would you be okay with that? They said, of course, let's try it. So they did that, and they completed the test in 11 hours. So safety, getting it done quicker, and then the accuracy of the test. We have a third company, a third customer. Each one of these is a different location that they have a very, very rough track with a very, very specific route that the drivers have to drive. They want each of the wheels to be hitting a particular event at a very specific time and at a very specific velocity. And that changes as they go around the track. And so most of the driver scores are in the high 70s to low 80s as far as accuracy to the test profile. When they got their first robot, they put it in, and at the end of the first 8-hour shift of running, they pulled up their numbers to look at the accuracy for that shift, and they were running at 97%. So they get the results faster and more accurately using the robots. We know that a lot of time and effort goes into idiot-proofing the vehicles as they're designed, and a lot of this testing that's done is to test for people who use the vehicle outside of the kind of the what it was designed for. I have a son who's now 36, and I'm glad he made 36, because when he was a teenager, he took his Chevy Cavalier four-wheeling up in the mountains behind our house. Misuse testing at its extreme right there. Misuse use of the vehicle. So unfortunately, when people do these crazy things in vehicles, a natural result can be injury or, in worst case, death. And when that happens, these folks decide that, the vehicle shouldn't have done what it did, even though they were misusing it, and they sue. And when they sue, they go after who they believe, or the lawyers believe, have the deepest pockets, and that's typically your OEMs, right? Whether it's a Stellantis, a GM, a Ford, a Daimler, a BMW, whoever it is. And we've all seen these crazy, crazy lawsuits that are filed, and we think, how on earth? And then juries award them obscene amounts of money. So in addition to the health and safety and all those reasons for running these tests and running them as close to accurate as possible to real life scenarios, there's a pretty large financial liability that can be there. One of the folks that use our kit to roll the vehicle over in a very realistic real-to-life scenario expressed to us that the reason that they bought the robot and the reason that they're doing that is they have been sued in the past for people who have rolled their vehicles and said the airbags didn't deploy at the right time. So they wanted to have the data in hand so that if they were pulled into court, they could express to the judge and the jury that they had done everything in their humanly possible, utilizing non-human drivers, robots, to make sure that their vehicles were as safe as possible, and they couldn't be held responsible if things went beyond that. So a lot of reasons to reduce liability. Notwithstanding the danger, the complexity that are involved, the tests need to be run. In recent years, computer models and simulations have improved dramatically, but they still only go so far, right? They get the customer and they get the OEMs a lot of excellent testing. But that last mile testing, there's just no real substitute for real vehicles driving on real roads at actual speeds for appreciable amount of times, or real vehicles being run into a barrier at a variety of speeds and angles, or real vehicles, in all these different impact and misuse scenarios and durability scenarios. And that's what gives the most accurate data. Robot drivers can run the test precisely and as often as instructed. They're not flesh and bones, so they can take the abuse. They don't get sick. They don't visit the restroom. They don't get hurt. They don't get bored. They don't get tired. They don't get apathetic. I know I have had an opportunity to ride with customers on some of these tracks, and they take me for one lap, and that's enough. I don't want to do any more. But whatever it is, whether it's a mileage accumulation or whatever the test may be, it might be exciting to start, but the excitement goes away quite quickly. And robot drivers won't do anything to adjust the test to avoid discomfort, pain, or potential injuries. As well as providing for current tests, having robot drivers also really opens the door for tests that folks have wanted to run but couldn't with a human driver. So future testing it opens a lot of doors to things that you can now do because you don't have to worry about the safety of a driver. Another quick question. Do you folks see any roadblocks to using robot drives for impact, misuse, or accelerated durability testing? I know they're out there, so we'll have another poll. And if you don't mind, if you can see challenges, if you could just put those into the chat at the top of your screen, there should be a little icon with chat underneath it. If you click on that, it'll let you type a new message. So if you see responses, please put those in there, and we'll address them at the end if we have time, or I'll get in touch with you directly and address those.
Looks like we have 83% that say no and 16% that say yes, and a couple questions are being typed right now.
Super. I'll keep an eye on those questions. We have about 6 minutes left, so I want to keep going. And quick answer, do they need 5G to run? We're actually working on a solution where we'll be able to use 5G. We don't need it today, and we don't use it today. We use private network to run the robots, but we do have several customers and potential customers that have made that request, so we are working on allowing 5G. And Alan, that goes right into yours, connectivity. Connectivity can be a challenge, and that's definitely something that we look at. So as we have worked with a number of companies, you can see here some of the customers that we work with. We've had an opportunity to see the challenges that have come up. And so if you're having challenges with this type of an environment, please talk to us. And we've seen a lot of them, and we've seen how customers have overcome them. And we can share some of that information with you. The way that we do the testing is using a vehicle automation kit that has two parts, hardware and software, that go into the vehicle. On the hardware side, we have actuators that actuate the pedals, the steering wheel, the transmission. We have an e-stop button. We have the ability to switch between autonomous driver and manual driver. We have a roof rack that goes on the top. This speaks to the connectivity, Alan. As you can see, there are actually 4 radio antennas on there because we use we use a radio system that has redundant radios to try and resolve that connectivity issue. GPS, the dual antennas, we get very accurate data on the GPS side of things. We're able then to hook into the vehicle controls through the OBD to bring some of the data back to the control center, and then of course the computer that runs everything on the vehicle. And then on the software side, our Mobius software is our command and control software that has been honed and refined over 22 years now, actually. And it's how the user interfaces with the robot driver. And from this software, the user can tell the robot driver what it needs to do. It can create safe areas for the robot to operate in. You can operate multiple vehicles simultaneously on the same track or different tracks, all with one user watching. So there's a lot of options there that you have with the Mobius software. It's very powerful, and I'd be more than happy to talk about it more with you at when we have more time. We're down just a couple of minutes left available to us. So just to wrap up, a reason for using robot drivers, number one, you can get data that truly reflects the test's intent. Number two, you can get it faster with fewer delays. And number three, it's more accurate. Now, those are great reasons. But one of the main reasons to use them is you can get that data without the threat of human injury and liability. Even at shops that are union shops, safety is number one. And so that right there is often justification to put a robot in the vehicle, is avoid that human injury and liability. All of this means that your engineers and your testers are getting better results faster, and that results in better product to market faster. So you got to see some of the customers that are using this. We'd say don't get left behind. Feel free to reach out to us if you have any questions. I'll leave the slide up here for a few minutes. My email's up there, eric.budd@asirobots.com, and Jed's email is up there, jed.judd@asirobots.com. please, if you have additional questions or want more information, feel free to reach out to us via the email, and we will get right back with you. We've reached our time limit. I want to thank you again for taking time. I'll stay on for a little while. If you have any specific questions, I'd be more than happy to entertain those now.
Yeah, thanks for joining, everybody.
Thank you for having us.
Jason, it's always a pleasure.
Same here.
Hopefully we can make it out to see you soon.
That would be great. We have revised our radio network actually, and there's been leaps and bounds since the last time you guys were out here. All of our signal noise ratios are great. We placed a few more. We were able to move 2 that were in the inner circle, and the robustness has leaps and bounds.
That's
So,
fantastic.
That is fantastic news.
Are you expanding? You said, the